Dear students, having explained how to formulate a VAR model, now we consider what are the advantages and disadvantages of VAR model. First, we discuss what are the advantages of VAR modeling compared to the traditional univariate time series models and also simultaneous equations structural models, which we have discussed in detail. The first advantage is researcher need not to specify which variables are endogenous and which variables are exogenous. In the simultaneous structural equation modeling, some variables are treated as endogenous, some variables are treated as exogenous. Also, identification is required before estimation. Estimation is possible if and only if the equation is identified. But in the VAR modeling, there is no such a thing. All the variables are endogenous. And as all the variables are endogenous, the biases and prejudices of the model builder will not be transited into the model building process. That is one advantage of VAR over simultaneous equation models. The discretion of the model builder has no role in VAR modeling to classify variables into endogenous and predetermined. And as we have discussed earlier, to identify an equation, some variables will be missing from some equations. It is known as the identifying restrictions. And the Sims call it incredible. Sims call it incredible. That is classifying variables into exogenous and endogenous, and also imposing identifying restrictions, etc. So, in the VAR models, number of variables will be equal to number of equations because each variable is endogenous. If there are 3 variables, 3 equations, we take the lagged values of all the variables and we model it. And in order to see the interaction between variables, we use what is known as the block exogeneity or gradual causality F test to determine whether the lagged values of one variable as a block causes the dependent variable in each equation. That is the first advantage. The second one is, since in the VAR model, a variable depends not only the lagged values of its own, but also the lagged values of all the other variables in the model, plus the white noise error term, it gives a more rich structure compared to the single equation models. The structure of the data is rich as we are using lagged values of all the variables. It will be able to capture all the interrelationship between variables, the entire dynamics of the system, by specifying suitable number of lags in each equation. That is a second advantage of VAR compared to the traditional models. A third advantage is, in the VAR models, we have only lagged values of each variable. There are no contemporaneous terms in the right hand side, so that we can apply OLS to each equation. We can apply OLS to each equation, because lagged values will not be correlated with the error terms, known as impulses, innovations, or shocks in the language of VAR. So it is easy to estimate. In the structural equation models, in the simultaneous equation models, we cannot apply OLS because in the right hand side there are contemporaneous values. So we have to resort to indirect least squares, two-stage least squares, etc. to estimate the parameters. In the case of VAR, there is no such problem. In the case of VAR, only lagged values are in the right hand side, and by assumption they will not be correlated with the error term. So you can apply OLS to estimate the parameters of each equation. The fourth advantage is, VAR is more better for prediction than the traditional simultaneous equation models. It has been observed by econometricians that the predictions generated by simultaneous equation models are very poor. And this problem was pointed out by Lucas, and it is known as Lucas critique. From macroeconomics, you know the significance of Lucas critique in a world of economic agents with rational expectations. So the prediction capacity of VAR models is found to be much better than that of the traditional simultaneous equation models. That is, forecasts generated by VARs are often better than the traditional structural models. And it has been proved by Sims in a number of articles. Also remember this, the traditional simultaneous equation models lost their importance or their significance, especially after Lucas critique. So VAR models are alternative to the traditional simultaneous equation models. And in the VAR models, no distinction between exogenous and endogenous. It is rich in terms of the dynamics of relationship between variables. OLS can be applied to each equation. There is no need for identification. Predictions are better. Now let us see some of the disadvantages or problems with VAR. One problem with VAR is it is a theoretic. A theoretic means not based on economic theory. As we will study later, there is an area known as univariate time series modeling, popularized by Box and Jenkins, that is ARMA or ARIMA models. In the context of ARIMA model, we formulate YT as a function of lagged values of its own values or lagged values of error. That is AR, MA or ARMA, ARIMA, that we will see in detail. So ARIMA models are not based on economic theory. The philosophy is let the data speak for itself. In the same way, VAR models are not based on economic theory. As it is not based on economic theory, war models are not very suitable for policy purposes. War models are not very suitable for policy analysis. So the point is, it is less amenable to policy analysis or theoretical purposes, as it is not based on. Actually, war models are better suitable for forecasting, not very suitable for policy analysis, as it is not based on economic theory. The second disadvantage is the selection of lag length. Lag length. As I told you, selection of lag length is a very important issue in the context of war, but it will be automatically done by econometric softwares. The point is, you select the optimum lag by consulting the lag length selection criteria, which we have discussed earlier. The third one is, you have to estimate a lot of parameters. A lot of parameters. If you have 3 variables and 3 or 5 lakhs of each, you have to estimate a total of 48 parameters, like that. So you have to estimate a lot of parameters. If the sample size is small, estimation of so many parameters will consume a lot of degrees of freedom. That is a problem, especially when the sample size is small. And anyway, regarding that, we have no choice. If we have yearly data, you may not be able to get a very long data. So you try for getting quarterly data, monthly data, etc. There is no choice regarding this. The fourth is, a question asked is, should all the components of war be stationary? The answer is, all the components of war must be stationary. Stationarity is a requirement for war modeling. If the variables are not stationary in level, they should be made stationary by differencing. They should be made stationary by differencing. But a problem is, if you are using differential data, you will throw away long-run information, because once the differencing is done, long-run information will be lost. So you have only short-run relationship. An alternative is, if the variables are co-integrated, this is not at all a problem, because if the variables are co-integrated, we reformulate var or reparameterize var as VECM, and we estimate the long-run relationship from the data. So when you formulate var models, keep all these things in mind, that the pros and cons of var modeling. And remember this, causality should also be considered in the context of var models. The model used for causality is same as the model used for var. If there are 3 variables, and if your purpose is to detect grandeur causality, again you formulate it as a var. That is taking the lagged values of all the variables in the right hand side. Then F-test can be used to test the significance of each block, and this will be automatically calculated by the software Gretel available in the market free of cost. It is a free software. or you can use what is known as the Granger causality block exogenity test available in EVs.